Okay, last graph demonstration. This is a desmos demonstration set up for Vertex Form. So this is what Vertex Form looks like. And if you're not given a function in Vertex Form, you'd have to complete the square to get it there. But Vertex Form, as you might guess from the name, makes it really easy to spot where your vertex is. So I want to play around with this just a little bit again. So often we start from standard form. Like I said, to get it here, we'd have to complete the square. But once we've got it in this form, that A out in front, if we play with that, notice making it bigger, makes it tall and skinny, making it closer to 0, makes it really flat. Making it negative, flips it upside down. Big negative makes it steep. Once again, A actually has the exact same meaning. So that's one consistent thing. In any form of a quadratic, you should be able to look at the equation, look for that A that would get hooked to the x squared if you multiply it out. And that number should tell you whether the graph opens up, opens down, is tall and skinny, or is short and wide. Okay. The H and the K are what are new for vertex form. So if we slide this H around, right now H is 2. If I make H smaller, there's H equals 0, there's H equals -3, there's H equals -5. Notice we're moving left or right, and as H gets bigger, you can see the same thing. So the job of H in vertex form is to tell us the x value of the vertex. But you have to be really careful with this one because notice there's a minus sign built into this formula. So if the formula says x minus 5, that means the vertex is at +5. If the formula says x plus 5, then we want to think about that like minus and negative. Sorry, slow on the slider. There we go. If the formula up here said x plus 5, that actually means the vertex is at -5. So there's a sign switch that happens there, and that can get a little confusing. We'll talk about transformations in 141. So this whole idea of shifting something to the left or the right or up and down is tied very closely with vertex form. And in general, the x ones look a little funny in the equation, but for now, just know that there's a sign swap. So if it's x plus 2, the vertex is at -2. If it's x minus 3, the vertex is at +3. For K, what's hiding at the very bottom? There it is. Ooh, we could turn on the label. I like it. For K, if we start playing with just K, notice all that does is move the graph up and down. So it's similar to the C in standard form, but it's not telling us where, it does shift us up or down, but it's not telling us exactly where the y-intercept is. It's telling us the y-coordinate of the vertex. So if I let k equal 0, the vertex sits right on the x-axis. Let's move this over a little bit. Oh my goodness, so bad with the slider. If k is positive, the vertex sits above the axis. Notice we no longer have x-intercepts when that happens. If k is negative, the vertex sits below the axis. Now we have 2 intercepts. So vertex form is powerful in that it tells us whether the graph opens up or down, is skinny or wide, and it tells us without doing any extra work exactly where the vertex is. If we want to know where the y-intercept is, like right now, it looks like it's at 0, -3.25, we'd actually have to plug 0 in for x and crunch through this a times -h² plus k to find that. If we want the x-intercept, we'd actually have to set y equal to 0. And this one is really nicely set up to solve using square roots. So you could subtract k, divide by a, square root both sides. So you will have to do some work for any intercepts in this form, but the vertex is a freebie. Okay, thanks for watching.